Imagine stepping out onto a world where one side of your body could be cooking at 800 degrees Fahrenheit, while the other side freezes at nearly 300 below zero at the exact same moment. That's not science fiction. That's just Tuesday on Mercury. Today, we're putting a human being on the surface of the closest planet to the Sun and walking through exactly what would happen, minute by minute. Some of it will surprise you. One part of it will probably scare you a little. Stick around for that one. The moment you stepped onto Mercury, the first thing you'd notice is gravity. It's only about 38% of Earth's. You'd feel noticeably lighter, able to jump higher and move with less effort, similar to walking on the moon but slightly stronger. The ground beneath you would look almost identical to our moon. Gray, dusty, covered in craters from billions of years of asteroid impacts, with virtually no erosion to smooth anything out, because Mercury has almost no atmosphere to create wind or weather. And that's actually the first warning sign of something much bigger. No atmosphere means no protective blanket. No protective blanket means Mercury experiences some of the most extreme temperature swings of any object in the solar system. But here's the part most people don't realize. The real danger isn't just it's hot or it's cold. It's both. At the same time, depending entirely on where you're standing. If you were standing in direct sunlight on Mercury, temperatures can soar to around 800 degrees Fahrenheit, hot enough to melt lead. Without an extraordinarily advanced suit, you would not survive more than a few seconds of direct exposure. Mercury is so close to the Sun that sunlight hits it roughly 7 times more intensely than it hits Earth. And because there's essentially no atmosphere to scatter or filter that radiation, sunlight on Mercury isn't just bright. It's a direct, unfiltered, lethal beam of heat and radiation pouring straight down onto the surface. Here's the cliffhanger. You might think the solution is simple. Just find shade, right? Walk a few feet into the shadow of a crater wall, and you'd be saved. Except Mercury has another problem waiting on the dark side, one that's just as deadly, in the opposite direction. Step into shadow on Mercury, and temperatures don't just cool down, they crash. Without an atmosphere to retain any heat, nighttime regions and permanently shadowed craters can plunge to around negative 290 degrees Fahrenheit. In fact, some craters near Mercury's poles are so deeply and permanently shadowed that sunlight never reaches their floors at all. And inside those craters, scientists have actually detected something nobody expected on the closest planet to the Sun: ice. Frozen water, sitting untouched for possibly billions of years, hidden in permanent darkness less than 36 million miles from our star. So now you're standing on a planet where direct sunlight could cook you alive in seconds, and stepping into shade could freeze you solid almost as fast. There's no comfortable middle ground waiting for you to relax in. And it gets stranger, because Mercury has one more trick that messes with your sense of time itself. Here's something that sounds like a typo, but it's completely real. A single day on Mercury, meaning sunrise to sunrise, lasts about 176 Earth days. But a full year on Mercury, one trip around the Sun, takes only about 88 Earth days. That means if you were standing on Mercury's surface, you would experience 2 full years pass by before the Sun even completed one full day-night cycle. You could watch Mercury orbit the Sun twice over before the Sun set even once from where you started. If you watched the sunrise from the right spot, due to the combination of Mercury's slow rotation and highly elliptical orbit, the Sun would actually appear to rise, pause, briefly reverse direction, and set again, and then rise a second time, all in the same day. Astronomers call this rare effect a double sunrise, and Mercury is one of the only places in the solar system where you could actually witness it with your own eyes. Beyond the temperature extremes, there's another problem. Mercury has essentially no real atmosphere. What little it has is so thin that scientists call it an exosphere, made up of atoms knocked loose from the surface by solar wind and meteor impacts. Far too sparse to breathe, and far too sparse to carry sound. That means if you screamed on Mercury, even standing right next to someone, they wouldn't hear you. No air pressure means no sound waves traveling between you. The entire planet would be eerily completely silent, just footsteps you'd feel through your boots, but never actually hear. And without an atmosphere acting as a shield, Mercury's surface is also constantly bombarded by solar wind and radiation that would be completely lethal to unprotected human skin in moments. Radiation levels far beyond anything astronauts deal with, even on the moon. Even the ground has secrets. Mercury's surface is covered in a fine, powdery layer of regolith, similar to the moon's, built up over billions of years of micrometeorite impacts grinding rock into dust. But Mercury's crust also hides something unusual. Strange wrinkle-like cliffs called lobate scarps, some over a mile high, formed because Mercury's massive iron core has been slowly cooling and shrinking for billions of years, causing the entire planet's crust to wrinkle inward like a grape drying into a raisin. That means the very ground you'd be walking on has been physically shrinking under your feet for billions of years. And in geological terms, it's still doing it today. So here's the reality of standing on Mercury. Gravity light enough to make you feel almost weightless. Sunlight intense enough to melt lead. Shadows cold enough to freeze you solid. Silence so complete you couldn't hear your own voice. And ground that's been quietly shrinking beneath your feet since before life existed on Earth. It's a planet of brutal contradictions. Blisteringly hot and bone-chillingly cold, all within a few footsteps of each other. And Mercury, believe it or not, is actually one of the more survivable planets on our list. Up next, we head to a planet where the pressure alone would crush you before the heat even had a chance. Stick around.